Hey, Will King here. It's the On the Build Show. I want to talk about basement walls and the different systems that we use here on the lake. So here in Northwest Alabama, we're on the Tennessee River, and we build a lot of lake homes. And so we have gotten really good at daylight basements because most of the topography here is going to be sloping down to the water. So over the last several years, we have became not experts, but I would say we've become really good at putting basement foundations in. So there's really two types of basements that we use. That's going to be like superior walls, which are going to be precast walls, and we do poured in place walls. So we can do both. We often use both of them depending on the application. What we don't use, however, is CMU block. And so I will say that to start this video. You know, CMU block has too much potential for problems and movement and cracking. And if you're trying to build a nice lake home, I really feel like the best product you're going to get is either going to be those precast walls or a poured in place wall. So let's talk about the two of those. All right, so the one that we're in today is definitely a poured in place wall system. And we used poured walls on this project for several reasons. One of them being that subcontractor was already on site. We had to start down at the seawall and build a poured wall there, a poured wall behind it, and then actually one more at the top of the hill to hold the pool. And then we started the house. So because the resources are already here, it made a lot of sense. And we talk about retaining walls, superior walls are a no-go for those, or precast walls, because you know they sit on a stone footer versus a full concrete footer that's designed for retainage. So we talk about big footers and rebar, obviously we have to be in a poured wall situation. So behind me is a 12-foot wall, and that's going to be the deepest part of the wall that's underground here on the top side of the grade. But I didn't want the entire house to be 12 foot out of the ground. So, you know, we use 2-foot floor trusses pretty often on a full basement house, and that's so we can get all of our mechanicals ran through the trusses. We actually incorporate the chases in them so that we can get main trunk lines through them. You know, most traditional basements, that floor system is going to sit on top of the wall. So if we had a 12-foot wall plus a 2-foot floor truss, that would put us at 14 feet. But I didn't want the back of the house, nor did the client, to be that high in the air. So what we did, all right, the back wall is 12 feet, but we have 10-foot ceilings down here because that truss actually sits down inside the basement wall on the back, and then we have a stud wall here that catches the trusses, so they bear actually on this stud wall that sits down on the footer, by the way. And that's what holds the floor system up on the back of the house. And you can also do that with superior wall as well, by the way. So they make a skirt wall system that creates a lip that you can set those floor trusses on. In fact, we've done several of those, and we have another one in the works currently. But to save on concrete, it wouldn't make sense to make all the walls 12 foot tall because, you know, the grade falls off pretty hard on the side of this house. So you can see as this basement wraps around, it actually steps down to about a 5-foot wall or 4-foot wall. And then you just build your knee wall on top of that up to catch the floor trusses. And so eventually on the back side, it daylights out, and there we just have a wood framed wall. So let's talk about some of the details of this stud wall up next to the poured wall and how it's holding up our floor trusses and I guess all the pieces here. So you can see there's about a 1-inch gap between the stud wall and the concrete wall itself. It's always a good idea to hold that wall off and not let it touch. It allows you to get insulation behind it. And if there's ever any moisture wicking going on at all, it keeps it off the wood because the bottom, you know, is our green plate or our pressure treated lumber. So you have the protection there when it's on the concrete, but these obviously are not treated. So you want to hold it off that concrete wall. Now this will get flashed with closed cell foam. Now we're under grade here, so the part that's underground or under grade will just have closed cell foam in it. And as we come out of the ground, the portions on the side of the house going towards the river, they'll actually get flashed with closed cell foam, and they'll also get a rock wool bat on them as well. So it's important to have this stud wall on the inside because you also get to run all your mechanicals just like you traditionally would. But now you have to know the detail and which wall system you're using when you're planning your house because you have to draw the house plan accordingly because, you know, if you're using dimensions based off the concrete wall and then you built it and framed it, you'd be losing 4.5 inches right here. So that makes a big difference in the room dimensions. Now I will say one of the advantages to Superior Wall is that their wall systems are 10 1/4 inch thick, but the studs are included, so your drywall is going to attach to the face of those studs. Okay, so let's talk about some of the differences between superior wall or precast wall and a poured in place wall. I'm a big fan of trusses to start with, okay, whether that's floor trusses, roof trusses, etc. And I'm a fan of those because they're engineered and they're built in a factory, so you get a really good product when they're brought to the site. So if we translate that to basement foundation walls, that's what superior walls are. So when you get those on site, you know the exact dimensions, you know they're going to be perfect, right? But when you do poured walls, that may not be the case because there's a labor factor, a human error factor that you have to consider. So in terms of speed, you know, if we're doing superior walls and we have the CAD drawing from the manufacturer, we already have our floor trusses pre-built and ready to go. Whereas when we do a poured wall system, we have to wait until they're up and the forms are stripped off of them before we measure and then build our floor trusses. So it's a time saver in that regard. The big question I get asked all the time is the cost difference between the two wall systems. And obviously, project to project is going to vary. Sometimes we're going to be more cost effective with superior walls. Sometimes we're going to be more cost effective with a poured in place wall. But I have seen about a 10% difference in superior wall being cheaper than a poured in place wall. And that's a rule of thumb, but it is a good benchmark, and it's going to speed up time, and it's going to speed up waste and overall just job site cleanliness too. So we talk about waterproofing. That's another important detail of both wall systems. So with poured in place walls, there has to be an applied waterproofing system on the outside because the concrete itself is not waterproof. So that's going to involve some type of spray-on membrane or peel and stick membrane, plus a capillary break on the outside to break that pressure, and a drainage mat to allow that water to get down to your drain pipe. Now with superior walls, they actually give you a warranty with no additional waterproofing. So that is a factor to consider. However, I will tell you, as a builder who likes belt and suspenders approach to things, I would encourage you to go ahead and add a capillary break and a waterproofing system to that wall system on superior wall, just so that you can make sure 30, 40, 50 years from now, your clients never have a problem with that wall system. But if you're looking at the cost between the two, you definitely want to consider the waterproofing as an add-on to poured walls that's not necessarily required for a superior wall system. So one big difference between the two wall systems too is going to be one has a stone footer, superior wall. One has a concrete footer, and obviously that's the poured in place wall. You know, I was a little skeptical at first when I heard about superior wall just sitting on gravel and not sitting on a solid concrete base. Their engineering team is going to spec this wall system, and they're going to tell you how thick and how compacted that gravel needs to be, and they're going to inspect it when they come to set the wall systems. So the one thing I like about that is the fact that water has a complete drainage plane, not only down the outside of the wall, but under the footer, and then all the way out the daylight into the basement. Because when you dig the basement for superior, you're going to have a little bit of a slope on your grade or on the dirt that you're digging. So that water that gets underneath the slab has the ability to drain outward, okay? And it's not trapped by the footers. And that's the big thing about that, is that it's not trapped. Because obviously water can flow through gravel. So again, you have a continuous path. It's down the outside, under the walls, and then all the way out to the daylight side. I feel like when you have footers sunk in the ground, it actually ends up holding that water and keeping it from escaping, and in turn building up hydrostatic pressure, which is what we don't want in terms of water leaks. All right, so hopefully you learned a little bit today about the differences between superior walls and poured in place walls. You know, if you're a builder or a homeowner and you're planning your next project, I would encourage you to explore both, price both, talk to your architect and your engineers, and figure out which system works best for your project. If you're not following us already on Instagram, please go do so. It's @WillKingBuilds. Guys, just remember, iron sharpens iron, so keep grinding, keep watching these videos, and we'll see you right here on The Build Show.